things that add negative 7 and multiply to positive 12. 3 get a point. Negative 3, negative 4 does add to negative 7. Negative 3 times negative 4 is positive 12. That's a great job. If this was set equal to 0, what would our two zeros be then? I heard it first from Kelsey, so I'm going to give it to her. Okay, number 9 is one that's going to make me cry if someone misses it, so don't tell me unless you're positive. 3 cubed is 27. Yes, I agree with that. 3w plus 5. 9w to the second minus 15w plus 25. Kelsey's been gone for like a week, but she somehow nailed it and is getting 2 points for that. Yes. 3w cubed is 27w to the third. Yes. 3w cubed is 27w cubed. She's right about that. And then 5 cubed is 125. If we remember SOAP, same sign, opposite sign, always positive. She did 3w and 5 in the front two slots. 3w squared it, so 3 squared is 9. W squared is w squared. 5 squared is 25. She multiplied the two together and got 5 times 3w. That's minus 15w. That's perfect. Beautiful. Good job, ma'am. And then number 10 looks like a guess and check. Why do I say that? Yes, 1, because the leading coefficient is 2. I think that's what you said. That's what I'm going to pretend you said. Okay, cool. So I know it's a 2n and an n because I need 2n squared. My question in the question mark parts is what goes in the other slots. It needs 3 and 3, you think? Okay, well, we have options because with 9, you know it could be a 1 and a 9 or 3 and 3. And yeah, I get we got to have one of them negative. I get that. He says it's going to be 3 and 3. So maybe a minus 3 and a plus 3? What sign did you want? One's got to be minus, one's got to be plus. Where did you want them? Did you want the minus here or the plus? No,
I'll have the plus to where with the add.
Okay, yes. So just like this then?
Like the negative with the add. Negative 3 with the add.
Okay, he thinks it's supposed to be like this. He might be wrong. He might have to come back and change the signs. Or heck, it might not even be 3 and 3. It might be 9 and 1. But let's check and see. So 2n squared would be first. Outer minus 6n. Inner plus 3n. Last minus 9. Did we succeed? No, because we got a negative 3n for the inner. Because when we combine those two, we'll have a minus 3n. We need a plus 3n. So we need to change things.
So it would have been the way that it should have been instead of
yes. Okay, I heard it from most people. Especially Arturo. Arturo, you're the one who guessed it all. You can have the point. If you FOIL it out, 2n squared plus 6n minus 3n minus 9. Finally, when I combine 6 to negative 3, I get that positive 3. That's good. That was good. Okay, are there any questions about these math workshops? We've been factoring for freaking forever. Thank goodness we get to do some simplifying square roots tomorrow. Good gravy. I'm tired of factoring. Okay, let's go to your packet from yesterday. We started with finding the sum and the difference, the product and the quotient of functions. We decided that was no big deal. The only thing that's really changed in our life is notation. So it said like f of x plus g of x, and while we're not used to seeing that function notation, we are actually used to adding things together. No big deal. Same thing with subtracting. No big deal. Multiplying is no big deal as long as you remember to distribute correctly. Most people nailed that, and they even nailed division. Division has one tiny issue. The good news is with division, you don't have to do synthetic, you don't have to do long. We're really hoping that the numerator can factor, so it will cancel with the denominator, but it's okay if it doesn't. It didn't on your checkpoint. It's okay if it doesn't. But when the denominator doesn't go away, there is a scary number that we cannot use because it would make the denominator equal to 0. If you're trying to figure out what this no-no number is, what's going to affect our graph, you can set the denominator equal to 0 and solve, Or maybe you just see it in your head and you knew negative 4 plus 4 is 0. But if you don't know what to do, take the denominator, set it equal to 0, and you'll figure out where that spot is. In fact, it was worded the way it's supposed to be worded. I don't know if the words came out correctly yesterday or not. It's called a restriction in our domain. And the reason there's a restriction is because if we plug in that number, we would have 0 in the denominator, and that is not allowed in math class. Okay, yes, dear. Yes, dear. Okay, we discussed yesterday that you were supposed to do, flip to the next page. Flip to the page after that. Keep flipping until you get to it. You were supposed to do the page that says study guide and operations. You're supposed to do the bottom 5. They're due tomorrow. When I stop rambling today and you finish your checkpoint, you can gladly work on these 5. Why are these 5 problems going to take you some time?
You're going to do all of them.
And yes, but be more specific, Paige, and I'll give you a point.
You got to divide, multiply, add, and subtract.
Yes, and Paige gets the point. So each problem requires 4 things. On number 1, Seth has to add, subtract, multiply, and divide those functions. On number 2, he has to add, subtract, multiply, divide those functions. He's got a lot to do per each problem. It's a pain in the rear. So that's why it's going to take some time. Yes, it's only 5. It's going to take some time. You probably don't write tiny enough. You probably either want to show your work on the back, or I don't know, I would probably my own paper. That would be wise. Okay, let's back up a page. So that's what we're going to work on when Miss Compton gets done rambling today and after you pass your new checkpoint. Let's discuss what your new checkpoint is on and your new material for the day. We did. We're doing 2 this week. We're freaking awesome today. Okay, back up a couple pages to the page that has a box that says composition of functions. It is 2 pages before that 77 we were just on. Back up to this one. We're going to talk about it because it is a lot of fun, but people get it confused. So we have to pay very close attention. So today we're going to talk about function composition. And this is what concerns me. This, with a filled-in dot, means different than this with an open dot. That's the sad news. These 2 things mean 2 different things in math class. You already know what this means. What does the closed-in dot mean? Yeah, so that means multiply. But this new dot is our new operation that we're going to talk about today, which is called composition. Now, it's not hard, but again, you have to keep multiplication and composition separate. So is it an open dot they gave you or a closed dot? You got to keep track of which is which so you don't do the wrong math. Math teachers tend to be lazy, and we tend to use F and G over and over again. We can use any letter for a function. We normally do F because F starts with function, and we then go to G because G comes after F, and then can you guess it? The third most used is H. Like we get kind of lazy. We can use any letters we want besides X because X is already being used for function notation, but we tend to use F and G, so it either looks like the word fog, or sometimes we write it the other way. It's G open circle F, and then it kind of looks like, I know it's not golf, but it looks like golf, So we call them fog and golf. Now, could they use different letters and still want us to do composition? Absolutely. Literally, we're looking for the open circle. The open circle is how we know it's composition. But, again, math teacher's lazy. We tend to use F and G, so it tends to spell out the word fog or golf. Okay, so function composition is a whole bunch of fun. In fact, can we go first to, I want to go first to the problem on the next page, number 1 on the next page. Let's look at it. It even says find fog and golf, if they exist. Okay, so they asked us on number 1 to find fog. And you're like, I understand that means there's going to be an F and a G, but I don't know how to find fog. It's actually really easy to find fog. I don't know who started with the open circle, because it's so much easier when we write it like this. What fog actually means is that we want to know f evaluated at g of x. One lose a point. We want to know f evaluated at g of x. So when you hear the word composition, I think of music. And when I think of music and music composition, I think of when they mix all the parts together. And that's what I think of when I think of fogging off. Somehow we're going to use f inside g, mix them together, and get an answer. So you and I both know we spent a long time on how to evaluate a function. If we had f at 3 equals this, then you would say everywhere there's an x, put in a 3. Isn't that what you would normally tell me? The inside thing, you plug it in? Or if I said f at cupcake, then everywhere you used to see an x, you would put in cupcake. So today it says f at g of x, so f of x used to be negative 3x, but we don't want to use x. Everywhere you see an x, it used to be negative 3x. So f of x was negative 3x. Everyone's cool with that. It used to be negative 3x, but they're telling us, hey, instead of using x, everywhere you saw an x, can you plug in what's g of x? And since g of x is 5x minus 6, everywhere we used to see an x, we're going to put 5x minus 6. So let me say that again. It used to be, and I'll even work a problem below. If the problem had said f at 2, you would have said it's negative 3, and instead of the x, you would have put in a 2, and you would have said it's negative 6. Is everyone good with this line? I'm just making a problem up. Is everyone good with this line? It used to be negative 3 times x. If they had said f at 2, then everywhere you saw an x, you'd put in a 2, right? So that's exactly what's happening today. One lose another point. I don't know what you're doing, but you're on my nerves. That's exactly what's happening today. Everywhere we see an x, instead of putting x, we're going to plug in g of x, which g of x happens to be the function 5x minus 6. So everywhere I used to see an x, it used to be negative 3x. Instead, I'm going to plug in 5x minus 6. So it's just like this, except we're going to require a little more math. Okay, so let me write it again because I just can't stand it the way it is. F of g of x. So it was negative 3, and then we plugged in. It was negative 3x. Everywhere we saw an x, we plugged in that 5x minus 6. So it's negative 3 times 5x minus 6. From here, can we, of course, do some math and distribute? Absolutely. So we would have negative 15x plus 18. Okay, so that's how we find fog. So let's go to number 2, and let's find fog again. So number 2 says we want to find fog. So we want to know f evaluated at g of x, or f composed with g of x. So everywhere in f, I used to see an x. Instead, I'm going to plug in what's g of x. So it used to be x plus 4, that's a 4. It used to be x plus 4 for f, but it says everywhere in f that I see an x, I'm supposed to put in g of x. So in this blank, that used to be the x plus 4, in this blank is where I need to plug in poor g of x. So g of x is x squared plus 3x minus 10. So f was x plus 4, but they told us to plug in g inside f everywhere we saw an x. So instead of x plus 4, we have what g was plus 4. And of course, we can simplify this and have x squared plus 3x minus 6. Okay, and you're like, maybe I sort of understand. Third time's the charm, right? Third time's the charm in life. I do. I leave it there. I'll leave it there. And we'll come back and talk about what all this means in just a second. Okay, let's go to number 3 and go ahead and fog it. So if I want to find the function composition f of g of x, that means I'm wanting f evaluated at g of x. So f used to be x squared plus 3x plus 1. But now, instead of an x, everywhere I used to see an x, so those plots, the x squared plus 3x plus 1, I'm going to plug in g. And g just so happens to be x squared. So I'm going to put an x squared here and an x squared there. So literally, I'm taking this dude and plugging him in everywhere in f that I see an x. Now, this one's only tiny bit more complicated because I got to remember my rules of exponents. Since I'm raising powers, I multiply. So I get x to the 4th plus 3x squared plus 1. But besides that, literally everywhere that Paige saw an x in f, she plugs in what g is. Okay, before I make life any harder, are there any questions about fog? Yes, ma'am, Kelsey, you had your hand up. Okay. Everyone okay with fog? Okay, well, what stinks is, you know when you multiply, like 2 times 3 is the same as 3 times 2, so it doesn't matter what order you do it in. And same with the adding, you know, 3 plus 2 is 2 plus 3. It doesn't matter which order you do it in. Sadly, function composition, it matters. Fog and Goff can give you 2 different answers. A pain in the rear. So let's go back to number 1 and find Goff. So we found fog. Good for us. We did it. We still need to find Goff. We still need to do g of f of x, which sadly means everywhere in g we see an x. We're going to plug in f of x. So it's the exact opposite. So g is 5x minus 6. But instead of 5x minus 6, I'm going to plug in that negative 3x. Does everyone understand why these two are different? Okay, so again, it told me the outside data is g, so I know I'm using the g, 5x minus 6. But again, it told me at g to use f of x instead of x. So instead of 5x minus 6, I did 5 negative 3x minus 6. And if I go to my next line, I'll get negative 15x minus 6. Do these two answers match? No. No. We'll talk about tomorrow because we're going to keep doing this again tomorrow, sad day enough, because sometimes they're supposed to match. But it is quite all right if they don't match. Negative 3, so I did negative 15 minus 6. Why would it be minus? I thought it's just 5 and that one multiplied, right? Yeah. I know I wanted to make it harder, but it's not. I wanted to, but it's not. Okay, sometimes these might match, and we'll talk about what that's called when they match tomorrow. But as for today and for life in general, it's okay if you aren't twinsing. Unless they use a specific word, you're not supposed to be twinsing. Okay, so we found fog and Goff on number 1. Let's go to number 2 and find fog and Goff. Okay, so I want to find Goff. So I want g at f of x. So g, and this one is complicated, g was x squared plus 3x minus 10. Because g is on the outside, and that's what g was. But everywhere I see an x, so those 2 blank spots, I'm going to plug in f. So it's going to be x plus 4, and then x plus 4 again. Why did I take the time to write it in parentheses? Why does that matter? What if Gracie doesn't put it in parentheses? Then what happens? Well, let's even ignore that part. If she just put x plus 4 with no parentheses, wouldn't she say 3x plus 4 instead of 3x plus 12 on this next step? So she would already have an error. So if I were you, I would make sure I'm putting a lot of parentheses in my problems right now. Okay. If we distribute that 3, how about we do it opposite? Every group except 1 get a point. 3x plus 12 minus 10. Everyone cool with this? You and I both know we still need to deal with that. Yeah. We're going to have to FOIL it, so maybe I should over here to the side. If you need to write it out, you can. Is it bad that at this point I think you should know it in your head? So I already know it's x squared plus 8x plus 16. Plus 4x plus 4x plus 16. So in my mind, I seriously can already jump to x squared plus 8x plus 16. And if you understand how I'm jumping there in my mind, there's no need to show all of this. But I need to go back to my problem and add that in. So x squared plus 8x plus 16. But again, if Gracie hadn't put it in parentheses, she probably just would have done 4 squared and just had x plus 16. Instead of x squared plus 8x plus 16. So we can see how Gracie made 2 different errors, all because she didn't use parentheses. Okay, we need to combine us some like terms, and we'll be done. I've got my x squared, my 8, and my 3. Give me an 11. And then, oh no, 16, 12, and negative 10. What does that give me? And 2 gets the point. 28 minus 10 is 18. Do these 2 answers match? No. So again, sad day, Fogg and Goff give us 2 different answers most of the time. It's okay. But if Arturo sees a Goff problem and he fogs it, he can see why he's not going to get the right answer necessarily. He's got to go in the order given. So if they give you Fogg, you got to go in Fogg order. If they give you Goff, you got to go in Goff order. Because otherwise, you're going to mess it up, and you really shouldn't. Because I know it's new to you. I know it seems hard today, but it's really not that deep. You just hadn't practiced it the way you have adding, subtracting, multiplying, dividing. Okay, let's Goff the last one, and then I'm done. I'll give you your chance to practice. If we Goff the last one, so I want to know G evaluated at f of x. Well, G is x squared. And f of x is something complicated. I'm going to put him all in parentheses. X squared plus 3x plus 1. So this one's our hardest one today. So again, G was just x squared. That's easy, except everywhere I see an x, I'm supposed to put x squared plus 3x plus 1. So now I have this whole thing squared. So I am going to have to write that out in order to get the final answer. Because I am going to have to super distribute. Sad day. I've got to give the x squared in this front guy to everybody in the back. Every group but 1 get another point. X to the 4th plus 3x to the 3rd plus x squared. Yep, x squared times x squared is x to the 4th. 2 plus 2 is 4. X squared, 3x, I get 2 plus 1 is 3. X squared times 1 is x squared. So I did that one. Now I've got to go to distribute that 3x. So 3x times x squared, that'll give me 3x to the 3rd. 3x times 3x, that'll give me 9x. 3x times 1, that'll give me plus 3x. And sad day, I'm still not done. Yes, dear.
9x squared.
That is. God bless you, Archer. Get another point. I don't like it when I make typos. I appreciate that. 1 times x squared, I get 1x squared. 1 times 3x, I get 3x. 1 times 1, I get 1. And so sad day, I had to distribute the x squared to these 3, the 3x to these 3, and then the 1 to these 3. So it took a lot of time. And it took a lot of me paying attention. And heck, I didn't even do that great of a job, or sure it had to catch me. Okay, if I combine my like terms, x to the 4th is on its own. I've got an x to the 3rd. I've got an x to the 3rd. I think that's all my x to the 3rds, right? Yeah, so it's 6x to the 3rd. I got a 1x squared, 9x squared, 1x squared. So that's 1, 10, 11, x squared. I've got a 3x, I got a 3x, a plus 6x, thank you, and then plus 1. Perfect. Perfect. Okay, so fog and golf, we're doing function composition today. Are there any questions about this? I'm not going to give you the checkpoint today. We'll save it for tomorrow. Although I will tell you, it would be wise of you right now, if you're not trying to come see me 1,000 times tomorrow with this checkpoint, it would be wise of you right now to try. Where are they? Where are you? Where did you go in my life? I don't need you to write yes or no or anything, but it would be smart of you to try 4, 5, and 6 at the bottom of the next page. That would be so smart of you to go ahead and try. And if you asked me nicely and wanted to go ahead and get the checkpoint because you understand it's going to take some time, that would be awesome. Yes. Oh, I think I gave it to you. I didn't explain how to do 1, but you're good. You're smart. We're going to run away early. You know, y'all are on my nerves today. You better have a message day tomorrow. How many pages?
I should have known that.
Yes, that's exactly how I feel like today. Not bad. I don't know what Patrick can do with our documentaries for Patrick. I know. Patrick can probably be fine.
I was sitting down. Me and Seth weren't even doing it.
I don't know.
They were like.
I don't know what they were doing.
Love.
Oh, wait. Hold on. Take your rest. Braxton.
Yeah, we all sit in. I mean,
Yes, dear.
Are you happy that I'm here?
Yes, I'm married. Here's your paper. Hunter. Eduardo.
I think she did, but she was there because she left her hat.
It's a built-in number pads whenever she puts in grades. You know, use those little numbers up there, something like that.
I'm going
Arturo. No. You know me. Braxton. I don't know why I'm yelling at Braxton right now. As Valeria. How? Yes, ma'am. Eduardo. That would be great. Mackenzie. Kelsey. Natalie. Gracie. Eduardo. I have 2 minutes yours. There it is. And then don't walk away because it's your name is already. Okay. Will. So, Will, look at me. Plug in -3 into 8. Get the new number and then plug that into 8. Yeah, so plug -3 into 8. Get a number, plug that number into 8. Add. Gracie. Yeah, I would put it in my closet. I feel like that's cleaner. Healthy. Abby. How? Abby. No. I need to type right now. I'm not Paige. It was for you. One little side about it. I was one little side. Then
You don't need it again.
Brister.
This time I'm leaving Jerry with you today.
I appreciate that.
Where are we going?
Right here. You too. I did not realize that.
Today's my birthday too.
Stop trying to do you in the middle of first period. Today's my first class in the first period. Hey, look at us.
What?
Who? You. Don't start with me. You. How about you? And clips. Alright, thank you. Alright.
Oh wait.
Let me get out of your way.
Okay.
I wish there was like a 20-minute chill time in between classes so I could get my life together. What did he ask you?
If he could go get some water while you were still talking, and I said no. He needed